everyone, welcome to my channel Easy Learning. In today's session, we will be continuing with exercise 12.1 and that too from question number 3. We have already done till question number 2 in my previous video. Question number 3 is find the value of. So it means when the question says you have to find the value, it means you will not leave your answer in the exponent form. You will not leave your answer in any exponent form, neither in positive exponent nor in negative exponent. We have to calculate it and we have to find the value of the given terms. So first part, if you see, is 3 raised to the power 0 plus 4 inverse and into 2 square. So this is your question. As told you earlier also, we will write all the laws which we are going to use in the question. So first, 3 raised to the power 0. We know anything power 0, that's the 0 property of exponent is 1. So I can write here as 1. Now A inverse, the second law which we have done is anything power inverse is the reciprocal of it. So I can write it as 1 upon 4 and putting it 2 square as it is. Now 1 plus 1 by 4, both are unlike terms, unlike fractions. If I take the LCM, I will get 5 by 4. So I can write it as 5 by 4 into 2 square, which gives me 4 can be written as 2 square in then 2 square. In exponents, we do not cancel terms. It's not suggested that you cancel 2 square with 2 square. That's not the right way of doing exponents chapter. Rather, we should make use of the exponents property. Now, if you see in this particular case, the bases are same. It means 2 square upon 2 square. I can subtract the powers. 2 minus 2. This can go in the numerator, which gives you 2 raised to the power 0. So it can be 5 into 2 raised to the power 2 minus 2, which is further equals to 5 into 2 raised to the power 0. Now we will again write anything power 0 is 1. It means your answer is 5. 5 into 1 gives you 5. So it is not suggested in exponent chapter that you cancel the term. We should not cancel it like this. Otherwise you are also getting a 5 here. But that's not the correct approach. Rather we make use of the exponent laws to solve the question. So I have used the identity, which was a raised to the power m upon a raised to the power n is equals to a m minus n in power. So we have used the law to find the value of the given question. Let's see the second part of the question. The second part of the question is 2 inverse into 4 inverse bracket close, and then it says divided with 2 raised to the power minus 2. Now in bracket you see it is 2 inverse. So what we will be doing, we will write again A inverse as 1 upon A, right? A inverse is 1 upon A. So we can write it as 2 inverse as 1 upon 2. And what do we have here? Into 1 upon 4. To be divided with 1 upon 2 square, right? What it becomes? 1 upon 8 divided with expanded. Now in division, when you changes this to multiplication, we take the reciprocal. So this gives you 4 to the 8. It means your answer is 1 upon 2. So we have used this law to solve this question, where we have written A inverse as 1 upon A, right? Now let's see what is there in the third part. The third part is 1 upon 2 raised to the power minus 2 plus 1 upon 3 raised to the power minus 2, and in the last bracket we have 1 upon 4 raised to the power minus 2. Now I'll make use of the same exponent law here. A raised to the power minus m will give me 1 upon a raised to the power m. So it means I have to take the reciprocal of this term, reciprocal of this term, and reciprocal of this term. 1 upon 2 reciprocal is 2, and the power will be positive exponent now, plus similarly 3 and power I can write as positive exponent, and then 4 square. What it will be? 2 to the 4, and then 3 3s are 9, and 4 4s are 16, which gives you 16 plus 4 20, and 20 plus 9 29 is the answer. So we have used A inverse again. We have converted the negative exponent to the positive exponents, then expand it and then add up, you are getting 29. Let's see the fourth part of the question, which is 3 inverse plus 4 inverse plus 5 inverse raised to the power 0. Now we know anything power 0 is 1. But as per the BODMAS rule, we will first open the brackets. Let's see, we have A inverse is 1 upon A. So this can be written as 1 upon 3 plus 1 upon 4 plus 1 upon 5 raised to the power 0. Now if you take the LCM of 3, 4 and 5, what it will be? 3 4s are 12, 5s are 60. This will be the LCM of these three numbers. So taking LCM here, 320, this will be 20 plus 15, then 12 raised to the power 0. Now add it, this gets 5 plus 2 7, then 2 3 and plus 4 47 upon 60 raised to the power 0. Now I am getting one term whose power is 0 and that can be written as 1. If you are writing here directly as 1, that will be little incorrect because we have not solved the bracket here. So first solve it and convert it to single term which power can be 0 using the exponent law. A raised to the power 0 is 1. Okay, let's see the fifth part of this question, which is last part of question number 3. Fifth part, which is minus 2 upon 3 and its power is given minus 2 and then whole power with the middle bracket is given again 2. Okay, so what we can do here, a raised to the power m into whole power n can be mn. So if you see here, we have this is Rm and this is Rn. I can multiply it, right? So I can write it as minus 2 upon 3 raised to the power minus 2 into 2, which is minus 2 into 2 is what? Minus 4. So this becomes minus 4, right? Now I can convert it to the positive exponent. What it can be? I will be taking reciprocal of it because I know, right? So I need to take reciprocal of minus 2 by 3 will be minus 3 by 2. So it becomes minus 3 by 2 raised to the power 4. It means now minus sign, if I take it as minus 1 raised to the power 4 and then 3 by 2 raised to the power 4. Because minus 1 when you will multiply 4 times, which is an even number, right? So your answer will be positive. Now 3 into 3 into 3 into 3 upon, you have to multiply 2 into 2 into 2. How much? 3 3s are 9, 9 3s are 27, 27 3s are 81 and 2 2s are 4, 2s are 8, 2s are 16. So 81 upon 16 is the correct answer. With this part, I am done with question number 3. Please see my next video for question number 4, 5, 6 and 7. Till then, keep practicing and revise all exponents laws. Bye-bye. Take care.